Lookup and reference functions. Excel offers a variety of lookup and reference functions which can be used to pull data based on certain criteria or predefined conditions. While working through large amounts of data which run into rows and columns, often we might need to use some of the reference functions or lookup functions provided by Excel. Let's look at the key lookup and reference functions provided by Microsoft Excel. The first one is address. Address refers to the cell name based on certain criteria. Let's look at the syntax of the function address. The address function creates a cell reference as text given specified row and column numbers. Being self-explanatory, let's say we had to refer to cell number I10. Now that we know row number is 10 and the column number is, let's say we have to count manually 1, 2, 3, 4, 5, 6, 7, 8, 9. These were the first two arguments, which was the row number and the column number. The third argument is whether we want that reference to be relative or to be absolute. Let's say we need the reference to be relative. We press tab, comma, address returns an R1 C1 style reference or an A1 style reference. Let's select the A1 style reference and close the bracket, and we have I10. Let's move on to the next function, which is the row. The row function returns the row number of a particular cell. So is equal to row. The reference can be any cell. Let's say this is the cell we want to refer to. We close the bracket. Now since this cell was in row 17, row function returned the row number of that particular cell. Let's move on to the next function, which is column. The column function, in the same way row returns the row number, column function will return the column number for a selected cell. So let's say column. We can refer it to the same cell which gives us or describes the example. We close the bracket, press enter, and there we have the column number. Let's move on to the next example. Indirect. Indirect, in a way, creates a cell reference out of the row and the column specified in the indirect function. So let's say if we had to refer to L35, what we could do is we could simply link it like this. However, in case we need to use indirect, we manually type indirect. Now the reference text should be L35. We close it. L35, and there we have. If you would have noticed, indirect function asks for a text value. It checks back within Excel whether that text value corresponds to a cell in Excel. Since L35 is a valid cell reference and cell L35 contains the value of L, indirect function first converts L35 into a cell reference and then pulls the value of cell L35 in the current cell. Now let's see how this example has been made. Here, indirect function has been made flexible by giving us the option of selecting the column, and the row has been fixed as the row 35. So the first part of indirect function is F36, which is nothing but a drop down arrow containing all the column numbers, which is from H to P. The second part of the formula, second part of the function of indirect, after the ampersand, is the row. Now since row D35 will always return 35 as the number, we will keep having references such as L35, M35, N35 based on the value selected here. So L35, this cell is a value with 11. Let's change it to get the value in I column. Here we have 64. Indirect function referred to I, which was F36 containing the value of I, and the row D35, which is 35. This was indirect function referring to the same sheet. What if we want to refer to a different sheet in the workbook? Let's take a step back and see how different sheet references are made in Excel. Let's go back to one of our earlier sheets, plant 2, and copy this, Control C, come back to our existing sheet, and we create a reference by paste special, paste link. Now as you can see, the reference for a different worksheet is an apostrophe followed by the sheet name, apostrophe close, then an exclamation mark, $, H, which is the column, $, and 7, which is the row. An apostrophe is followed before and after a sheet name whenever the sheet name contains a space. In case the sheet name does not contain any space, then we don't need the apostrophes. The exclamation mark denotes that the reference is from a different sheet, and the formula after the exclamation mark is similar to a same sheet reference. Now let's look at how we can achieve this referencing through indirect. In the second example under indirect, we see that the sheet name has been inserted, which is plant 2, the column has been kept flexible, and the row again has been kept flexible to choose from. In the indirect, in row 47, we see the indirect function. The first part of the formula, if you look in the address bar, is the apostrophe, which is denoted and contained within double quotes, followed by an ampersand. F43 is the sheet name, followed by another ampersand. It is followed by the apostrophe to close the sheet name, then followed by an exclamation mark then the double quotes are closed, then another ampersand which gives us the column reference, another ampersand, and then it gives us the row reference. So essentially what this means is this is plant 2, column J, row 8. So if we had to manually type it, let's do that. Plant 2, J8. We had to insert a space between plant 2. Let's do that. Here we are. It's the same reference and the same value, and if we go back to this value, we have successfully created an indirect cell reference using indirect function. Moving on, the choose function. Let's say we manually add certain values here. And 1200. Now what if we want to choose the second value out of these values? What we would do is choose index number is the argument for the location or the number position of the value. Let's say we link it to this cell, and the value can be these. Let's press enter. Here we will have to manually describe all the values separated by a comma. Let's press enter. So if we change this value here, you can see that automatically if we select 1, the first value is selected. If we choose 2, the second value is selected. Now let's come to the formula before us, the example before us. In the example before us, as you can see, choose function followed by the reference to the position that we would want to, or the index number which we would want to refer to, then followed by 5 different sum formulas referring to the revenue figures of plant 1, plant 2, plant 3, plant 4 and plant 5. When we select 1, the choose function will source revenue for plant 1 from the plant 1 sheet. If we select 2, choose function will refer or source back revenue from the plant 2 sheet, and so on. So the syntax for choose function is the first argument is the position or the location or the reference out of the specified options, and the values are to be separated by commas, and choose function will, whichever number is provided to the choose function as the index number, it will automatically return that value. Moving on to the next function, which is the index function. Index function creates a list or an index of all the values provided to it, and we can refer within that list to various options or various values depending on the location of such values. For example, let's look at the index syntax of the index function. returns a value or reference of the cell at the intersection of a particular row and a column in a given range. Now, let's say that I index these four cells, or rather, let's simplify 3, 4, 5, 6. These are the values that we need to refer to. We say index and we select all of the cells. Only if we could scroll it up a bit, is equal to index. Oops. Yeah, now we can. The array will be this. These are the four values we need to index and refer to. The row number. Let's say we want to pick value number 6 from this index function. So the row number in this case is 2 and the column number as well is 2. Enter and we get 6. Let's change the row number to 1. What do you think should be the number? Correct, it's 4. So basically, index creates a database or a list and assigns unique values depending on the location of such values and cells within the index, within the selection, and we can specify rows and columns to pull such cells, pull the cell-wise information based on rows and columns. Now let's see how this is happening in the example before us. We have the dates, total assets, total liabilities, net assets, and the ask is to create an index function to pick year-end numbers for year 2013 and 14. Now, since you can see year-end values are appearing, since these are quarterly numbers, year-end figures for each of the year are appearing at the 4th and the 8th position. Now let's say I apply an index function. Here is equal to index, specify the array as this one, bracket, comma, and the row number is 1 because we are referring to the same row, and the column number is 4 in this case, bracket close. 16200. Let's check back if this is the value at year end, and it is 16200 at 31st December 2013. Now if you would have noticed, the formula given in your example, in your sheet, does not contain a row reference, or rather it does not contain this 1. Often when our index ranges or reference are linear, which is either one column or one row, we can conclude the function, index function, with just one argument, and that argument will be considered as the row or the column, whichever the case may be. So in this case, if we remove 1 and press enter, it will automatically decide that since it is a linear reference, we are referring to columns in this case, and it will return you the fourth value in the reference in the same row. Similarly, we can see that the functions for other years and other row items have been calculated using index. Let's see another example of index along with sum. As we know that index can pull a certain value, we can also use a combination of sum and two indexes to sum two values. Let's see how we can do that. In this example, The example asks us to create a sum function to sum for year and numbers for year 2013 and 2014 with support of an index function. Let's see if we had to use a simple sum function, how would we do that? Is equal to sum this number to this number. Correct? This is the sales value for the first year. Now let's look at how we can achieve it through an index function. Let's replace the sum parts, the arguments in the sum function one by one. First, let's replace the reference to the first cell, that is H81 in year 2013. We select index. The array will be the entire array. The row number is 1 in this case, bracket close. Let's go on to the second part of the formula of the function sum, index. It will be the same array, but the row number in this case would be 4. And let's close the index function as well. Now if we press enter, we see that the index function successfully computes the sum. Now let's go a step further to understand how we can further automate this sum plus index function. As you can see in the solution, the first part of index function is the same. However, the row number, the column number, which is Q78, has been referred to here. Instead of manually typing 1 and 4 in the previous case, we have referenced them to cells. Now in case we need to change the values or refer these cells to different values and different locations, we can always change these cells, and automatically the values here will get changed. For an example, if I had to simply replicate 43400, which is the result of FY14 or the year 2014, I could manually change it to 5 and 8, and the value will get automatically calculated for 2014. This was sum and index. Let's move on to match. Match is a fairly easy function. Let's say we have a list of data. In this case, it is the list of countries. And we want to refer to a particular country using the match function. Let's say match lookup value. Lookup value is the country we want to refer to. So let's say we want to refer to India. We type India in double quotes. The lookup array is the list of countries. The list of countries. Repeat from match. Now let's look at match function. What match function does is, it returns the relative position of a particular item from within the list. So let's say we have a list of items, in this case it is a list of countries, and we refer to a particular country, let's say Germany in this case. Now since Germany is at the third position in the list, match function will return the value as 3. Let's see how we can do that. Is equal to index is equal to match. The lookup value is Germany and the lookup array is the list of countries, comma. Match type gives us three options: less than, exact match, or greater than. In this present case, we need to have an exact match. So let's select exact match, bracket close, enter. You can see that match has successfully returned 3, which is the position of Germany in the list. Let's look at the example, the solution in this match example. We have applied match in the similar way we have done here, only that instead of typing Germany manually, we have referred that cell, the lookup value argument, to a cell which is E98. And in E98, we have a list of all the countries. So whichever country we choose, match will auto-compute the position of such country. This was the match function. Now let's look at offset. Offset function creates a reference out of a selected cell and moves or jumps the number of rows and columns specified in the function itself and brings back the value as per the rows and columns defined. To illustrate, let's say we have capex as 6000, which is year 2 capex. Now if we change this to 3, it will automatically pick capex for the 3rd year. Let's see how offset function can be used in such a case. Is equal to offset. The first argument is reference, which means that the starting point should be defined. Let's define the starting point of offset as cell G108. The second argument is rows. Rows means any number we input here will be the jump in rows from row 108. So if we put a 1, offset function will refer to row 109. If we put a -1, offset function will refer to row 107. If we put 0, the offset function will refer to 108 row itself. So for now, let's refer to row 0 itself, comma. The third argument is cols, which stands for columns. Now as you can see, the reference here, the starting point is column G, but we want to view capex amounts from column H onwards, right? So for column H, the column reference should be 1, which is adding 1. But now we want to keep that flexible. We want that to be like a Dropbox so that we can select the year and offset can source the capex for that particular year and present it in the current cell. So let's link this to the drop down here. Now for a moment, let's ignore the other two optional arguments, which are height and width, and close the bracket and press enter. Now as you can see, the values are matching. If we change the number of years to 4, it will automatically source the 4th year's capex amount. This was the offset function. Let's look at the other two optional arguments also before we move on to the next example. The height function is used to define the number of cells or the number of rows you want to jump at once. So let's say if we define height as 2, every row reference, so if we say 2 here and a 1 here, it will be a jump of 2 rows below row 108. Similarly for columns, it is width, and if we select 2 here and we have 4 as the selected year, offset will move to the 8th column, which is G So it will refer to column P in such a case. These were all the arguments for the offset function. Now let's move on to the next example, which is sum and offset. Just like we did in the example of sum and index, sum and offset are pretty much the same. Let's look at the function. The formula here is sum G119, which is the first blank, the first cell before any capex amount, separated by a colon, and then offset. So what it essentially does is, the sum formula here coupled with the offset formula will keep adding this cell and the specified number of columns from here. So if the value here is 2, the sum will add up the first 2 columns from G119. If we were to change this value to 3, let's just edit this. There is a slight problem with this particular cell. We can change it. Now let's say 4 of 4. Now the formula automatically computes the sum for the first 4 years, which is 22,000. This was the sum and offset function. To recap, we defined the sum function as G119 as the first cell, then separated by a colon, and then the offset function as before. Now let's go on to the next example, which is transpose. Transpose converts rows into columns, a specified data list from rows into columns, or vice versa. Let's see how we can do this. The number of rows, the number of cell values we have is 7. So let's select 7 columns is equal to, transpose is the function. The only argument is an array. So we select this, close the bracket, but before pressing enter, transpose is an array formula. We will have to press the key combination of Control, Shift and Enter. Format it in the date format. Let's say we can have from here. Apply the same background. The reason why we pressed Control Shift Enter is because transpose is an array function, and to run an array function we have to press Control Shift Enter. Let's move on to the next example. Index and match. We have already done index and we have already done match. Now let's combine these two functions to form a very powerful indexing or referencing formula commonly used in financial modeling decisions and financial modeling app. We start from index and match. Index and match. We have already done index and we have already done match. Now let's combine both of these functions to formulate a very powerful referencing function or formula. Before we get into preparing the formula, let's understand the question from the example before us. The example asks us to create an index formula to extract number of items ordered for the chosen product with support of match function. So what it essentially says is that here I will choose a formula, a particular product, and that correspondingly the number of units should be displayed in the cell below. Let's break these two. One is the index function. The index function should refer to the units ordered. Okay. Now, as we know, since this is a linear referencing, we don't need to specify rows and columns separately. We will just input one number which will serve as the column reference or the column number. In this case, it will be the row number because we are referring a column. Now let's say we need to pull out the number of units ordered for shirt. Let's manually calculate as to which position is the shirt on. Bag is 1, cap is 2, trouser is 3, and the shirt is on the 4th position. So let's put 4 here. We can see that we've already gotten the answer. But what if I didn't want to manually input the position? I didn't want to manually compute the position of the chosen product each time. Let's use match for this. You might also be aware that match returns us the relative position of a particular item. So let's say I want to know the relative position of shirt in the list of products. So what I do is I say shirt, the lookup array is this, the match type should be exact, bracket closed, and enter. So I've gotten 4. Let's proceed to combine these formulas. Let's copy this formula here. Okay, let's copy this entire formula. Go to this cell, press F2. Instead of 4, let's just paste this match formula, remove the is equal to sign, and press enter. Okay, so we are a step closer to working with index and match. But there is one more step we need to do to fully automate this function, this formula. If we click on F2, if we select this cell and click on F2, you can see that I had to manually type shirt here. What if I could refer this to the cell here? Now let's press enter. And we are done. Now the only task, let's delete these two. The only task that remains is to change this. Let's put it as bag. Let's put it as bag, and the index and match function will automatically compute and source the number of units ordered for bag. This was the index and match function. Now let's look at the lookup value. Before we proceed, let's understand the syntax of lookup. LOOK, lookup, press tab. Lookup value is the value we want to refer to in a particular list. So let's say I wanted to look up bag. Lookup vector would be the list in which I will search for bag, which is this, and the result vector would be the units. So lookup, much like index or repeat from lookup. So lookup, much like index function, has successfully referred to the number of units ordered for bag. Let's look at the example at hand. The example says create a lookup formula to A, find a value of 210 in the list, or B, extract number of trousers ordered. So let's say we are referring to 210. So look up 210 and look where? In this array, lookup vector. Lookups can only be applied to a single row or a single column. In case the lookup value can't be found, lookup will match the next smallest value. When lookup value is greater than all values in lookup vector, lookup matches the last value. So like in this case, since 210 is greater than all the values in the lookup vector, when we press enter, lookup matches the last value in that vector. When lookup value is less than all the values in the lookup vector, lookup returns NA. Result vector must be the same size as the lookup vector. So in this case, the lookup vector was product and the result vector was units ordered. Both of them should be of the same height or the same size. Let's look at the second task, which is look up for trousers. We say look up trousers trouser. Lookup vector is to be this, and result vector is supposed to be this. We close the bracket and press enter, and there we go. So to recap, when lookup can't be found, lookup will match the next smallest value. When lookup is greater than all values in the lookup vector, lookup matches the last value. When lookup value is less than all, that is the first value in lookup vector will return an NA. Result vector must be of the same size as lookup vector. And that is it for lookup. Let's go to VLOOKUP. VLOOKUP is a variation of the lookup formula, wherein we specify the entire data table that we need to search a particular item from. Lookup value restart from VLOOKUP. Now let's see VLOOKUP. VLOOKUP looks for a value in the leftmost column of a table and then returns the same value, returns a value in the same row from a column specified. So let's say VLOOKUP, and the lookup value is, let's say, a shirt. The table array has to be all the items in the table, including the lookup vector and the result vector, like we saw in lookup. Then the column index number. VLOOKUP only searches for or retrieves value from a table from top to down, which is column wise. So now, since we have the lookup vector here as product and the result vector here as units, we have already specified that we want to search shirt restart from VLOOKUP. The basic logic of restart from VLOOKUP. Now let's look at VLOOKUP. What VLOOKUP does is, VLOOKUP asks for a table as the data input or the data array. The first column of the table is the lookup column or the lookup vector, as we saw in the lookup formula. The lookup value shall be the value to be searched in the first column of the data table. So let's look at each one of them one by one. We've talked about lookup value, which in this case let's set as shirt. Lookup vector, lookup value is supposed to be shirt. Then table array is from bag to the last units ordered. Now VLOOKUP will automatically search shirt in the first column of our table array, which is in column D. The column index number prompts us to choose the column from which we need to pull out that value. So let's say we're looking for shirt, then column index number 2 will mean that in the same row as the shirt entry is, return me the value in the second column. The second column in this case is units ordered. So the moment I say 2, let's put the last argument as exact match, bracket close, and enter. So we have successfully used VLOOKUP to search for shirt in the first column and retrieve the corresponding entry in the same row in the second column. Let's change this shirt to, let's say, shoes, and we get the units ordered for number of shoes. This is the exact same formula that has been applied in the solution to this example, wherein F185 is being linked to a drop down, that is the lookup value, then comma, table array is from all the way to product down to the last units ordered, and the column index number is 2, which is the second column in the data array table. Let's go to the last of the lookup functions, which is HLOOKUP. HLOOKUP is exactly the same as VLOOKUP, only that it refers to different rows within the same column. So let's say I had to look up for shoes, and my data array was from all the way from bag to the last units ordered, which is 40, and I am saying that I want to refer to the second row. So it will refer to the second row for bag. Let's change this to bag. So what HLOOKUP will do is, it will refer to the second row in the data table or the array, which is starting from E to E192 to I193. So it will automatically pick up the second row, which is 200, the number of units ordered for bag. Let's change this to trouser, and it automatically changes to 120, which is the second row corresponding to the same column as the trouser. This was HLOOKUP.